right, in this example, we're going to find the local max and local min of f of x equals 3x to the fourth minus 4x cubed minus 12x squared plus 5. And this is using the first derivative test, which tells us that we get a local max if the derivative changes from positive to negative, and a local min if the derivative changes from negative to positive. So of course, we first have to find the critical numbers, because that is the most important part. And this, of course, should be a familiar function from our previous example. So the derivative will be 12x cubed minus 12x squared minus 24x, like so, which we factored previously and saw that's 12x times the quantity x minus 2 times the quantity x plus 1. And this gave us the critical numbers of x equals 0, x equal negative 1, and x equal 2. And we used the number line, we used our key idea to break up the number line with those critical numbers. Again, I'm going to label f prime below and f above. And then we picked specific values in each subinterval to figure out whether the function, whether the derivative was positive or negative, which means the function is increasing or decreasing. And what we found last time when we picked our x equal negative 2 down here, in this first subinterval, we got that the derivative was negative with the 12x, and then negative with the x minus 2, and then negative with the x plus 1. So overall that is negative, which means when the derivative is negative, the function is decreasing. Again, I'm going to draw that arrow there. Between negative 1 and 0, I picked x equal negative 1/2. And when we go back to our derivative, that's going to be negative when we plug into 12x, negative when we plug into x minus 2, and then positive when we plug into x plus 1, because we'll get negative 1/2 plus 1 gives us positive 1/2. So overall, this is positive for the derivative in this segment, which means the function is increasing. Between 0 and 2, I picked x equal 1. Plugging into the derivative, we get a positive for 12x, a negative for x minus 2, and then a positive for x plus 1. So overall, that's negative, which means the function is decreasing because the derivative is negative in that segment. And then in our last subinterval, I picked x equals 3. That's going to give us positive for the 12x, positive for the x minus 2, and positive for the x plus 1. So overall, the derivative is positive in that segment, so that means the function is increasing. Now, when we look at the arrows, and this is part of the reason I draw the arrows, it helps us to think about what we could be having as a local max or local min. And right here, we see the function is switching from decreasing to increasing. So that is a local min, as is suggested by the direction of the arrows. When we switch from increasing to decreasing, that is a local max. And then again, here we switch from decreasing to increasing, so we get a second local min. So overall, that means for local max, we have x equals 0, and for local min, we have x equal negative 1 and x equal 2.